Dan, you had a question.
Did they actually deliver that at 2:20 in the morning?
Yes, they did. It wasn't easy, but actually they called me that they are not going to deliver it at all, not on Christmas Eve and not on the first Christmas days, 26 and 27, and I have no idea how Force 10 convinced FedEx to deliver the stuff on Christmas Eve in the middle of the night somewhere in Berlin. No, it was 2:20 a.m. It ended up in some storing space, and they delivered it, I think, at 7 or 8 in the morning. I wasn't there.
8 in the morning, yeah.
8 in the morning in the CCC Berlin on Christmas Eve. Sorry? Okay. But then we had to transport it from there to the building here again, because the BCC was closed on the 24th, which, yeah, it was heavy. Okay. Issues.
Outages and issues and outages. We had a bit of a tough time with our core router, which was a Foundry RX8. It started out with a broken switch fabric module. It had been acting up in Amsterdam a little bit, but for the rest worked fine. Until we started experiencing weird random connectivity problems between hosts connected to the router, to a switch behind this router, and then not being able to do anything. They could ping the default gateway, but they could not actually access the internet. They got the HTTP, but nothing beyond that. We first suspected this was a broken switch fabric module because traffic passing through the switch crosses a switch fabric module, and it had been saying a few weird things during boot up about them. So we powered them down one by one, and one switch fabric module, when we powered it up again, said, "Oh, actually, I did not pass my power on diagnostics." And then took down the complete switch, which kept on logging weird messages continuously, so we had to power cycle it to get it back into something working order. There was a lot of broadcast traffic going on, a lot of station movements, and this leads to high CPU load on the line cards. Also, combined with the third issue we had, the line cards ran out of IPv4 next hop memory space. I'll get into more detail about that later. These three are all related. So this is the switch fabric module power on procedure. As you can see, it powers on the SNM, and immediately traffic just stops flowing. There were a lot more syslog messages about internal stuff breaking. The first one was about a IPv6 BGP session. And all the rest died, all the OSPF neighbors disappeared, because apparently it did try to pass traffic over this switch fabric module, which of course wasn't forwarding it, because it said it didn't pass its own post. Line card utilization, this was pretty low. This is taken this afternoon, but during the second day especially, we ran easily with 99% CPU load on the top two line cards. The first two line cards helped the 10 gig links downstairs and to other big areas. So they had lots of ARP, lots of next hop entries to resolve. And this was caused by a design feature of this particular switch. It has a command where you can increase the ARP table to 64K entries. We noticed on the first day that we had forgotten to do that, and the default was at 8K entries, which we quickly ran out of. So we raised it to 32K entries, which is the maximum you can get with the /17 of IP addresses we had actually allocated to various places. And rebooted the switch, thinking, okay, now we're all set. Now we can sit back and have a beer and hang out. So not long after that, the switch syslogged the message printed in red below. And it says info, but what it actually means is help, help, panic, at the very least. So we ignored that for a while, thinking, well, it says info and next hop entries. Maybe it can create some more. So it started saying this, and then we started looking at the switch fabric module that was broken, and we thought, well, okay, if we yank that out, and maybe then it helps. Help these weird connectivity problems that had been starting around the same time. not knowing how to check for next hop entries, and we looked extensively at documentation provided by the vendor, and we couldn't find anything about next hop entries anywhere except in a cut and paste from a configuration example where the command usage for something was shown but not explained at all. So no help whatsoever, in short. We do have a gold support contract on this machine, however. So we opened the case. It says priority 3, but that was the final priority once it was clear that it really wasn't going to work anymore. So we opened the case asking, well, we get this message, and we also get a lot of connectivity problems. Are these two interrelated? So I was on the phone for quite a while with support. They looked at the switch, they typed a whole bunch of commands. I heard busy typing all the time. They conferred with engineering, and they came back pardon. They came back with the message that this particular model indeed supports 4096 next hops. And an ARP entry takes up at least one slot in this table. And well, with the ARP spawns running, we had about 25,000 entries in the ARP table, which happily overflowed this 4K next hop table. So a lot of people could ping their default gateway because that goes to the CPU level, then the CPU sends it down to the line card and that just pushes it out, but traffic through the switch needs an entry in this next hop table. Traffic being routed in hardware needs an entry in this next hop table, so it just didn't work. So a lot of people on the second day of Congress, quite some people had issues that they could ping the default gateway, they got the DHCP address, but they couldn't ping anything besides that. This happens sporadically for people. I'm not quite sure how many people actually suffered from that. I see a few hands. I see all of the hands. All right!
Okay.
At one time or another. Well, after we found out this, we disabled the ARP sponge, we cleared the ARP table, and since then we have not seen the message since, and since then also the help desk has been eerily quiet about network issues. So yeah, we had this bug closed, and we will, however, still take this up with the vendor because it's not really nice that it's 4K next hops is for an event as this is not enough, because we have 30,000 IP addresses handed out, assigned to various subnets, and it means that we're limited with this particular piece of hardware, if we use the network design we used here, to about 4,000 concurrent users. Right, so this was the interesting part. This is a connection to a line card in this switch, which of course is not documented, is not recommended, unless under guidance of a tech engineer. And it clearly shows that Houston indeed has a problem. After we killed the ARP sponge, that is a piece of software that answers for ARP queries that go unanswered, therefore reducing the level of broadcasts on all networks. After killing that and deciding to basically live with the high broadcast levels, you see that this freed up quite some next hops in this particular bit of memory. That was, by the way, unsizable in any way. Yes. Graphs.
Graphs, more graphs.
To you.
Yes, some of you might have seen that already earlier today, but I thought while talking about the core traffic, we should show that again. That is the whole traffic going over the core router, the Foundry box. And it's quite more than the IP upstream Stefan already showed, because a lot of traffic was only inside the building and into VLAN routing, and it was only going from different subnets or different levels inside this building. So we got up to 5.5 gig traffic on this core router. IPv6 traffic inside this building during the last day was also up to 200 megabit, which is, like I said in a presentation before, that's almost the same amount of IPv6 traffic that the M6 Internet Exchange in Amsterdam is doing in IPv6. So we have some IPv6 power users here, I guess. of people not turning off their IPv6 on Apple PowerBooks. What is that? Total?
A85.
A85, exactly. That is the traffic coming from the Force10 located in level A, where the co-location was and all the Hack Center HP switches connected to, and going upstairs to the core router, which was quite a lot. And it started out on Wednesday with the, when did we finish the build-up?
Wednesday morning.
Wednesday morning, so Wednesday afternoon, all the people started.
Well, Wednesday morning, the service arrived.
I patched level A on Wednesday afternoon, I think, so that's why it started exactly there, too. The upstream going to...
The same number that Stefan asked.
Same number, exactly like before.
This graph is monitored from the inside and not from the outside. So, different measuring point.
Our statistics, More? The total traffic over the last day, starting on Wednesday. Of course, more outgoing than incoming traffic, but
clearly some outages visible.
The peak, the drop you see over here, that is exactly when we experienced the RX problems with the core router, and we had to reboot the machine a couple of times during this day. I don't know, 2-3 times in the end.
3 times, I think.
3 times in the end, within like 3 hours or something like that, and that caused a dip in this graph. But after that, it seemed to work quite well again. We had a lot of traffic going on. Percentage of V4 and V6 traffic on the network already seen in the SFlow talk before. 6.6? Is that the same graph as before?
Yeah. This is the percentage graph.
Yeah, I think so. Okay. And Maxim, now more about the wireless.
So I will now speak about actually what we did to make the wireless network work and what we do for preparation and what we done last year. So first of all, a short agenda. I do a recall from last year and then preparation and design. What actually we done before the event started. 1 month before we started to organize the stuff, and today I can say we have finished in about 3 days of setup. So then later about the topology, performance and security, and monitoring for our station troubleshooting. At the end, statistics and the outlook for next year. So what was last year? We had 36 access points, single mode, ABG. It was located all over the building. We had no special focus on lecture rooms or rings or the Hack Center, where the most people were located. But therefore, we had only 4 access point and 5 GHz mode and very low coverage for that. The Aruba switch we used last year supported maximum 512 users at the same time. We used 509. Average was 350. So we run very on top of the box. We experienced high performance issues because we had stations where more than 150 people were located, and they all were using B or G. So it means you have only less than one megabit actually per user. Performance issue came from ARP spoofing, and performance issues came also from people were making denial of service attacks and so on. It's the normal stuff. Of course, last year were the numbers of rogue access points also quite high. I think about 50 or 60 access points. So what we do changed that year. For planning the whole building, we used AutoCAD this year. We're not